talking about changes. Prices going up, prices going down. Quantities going up, quantities going down. And we're going to talk about how that relates to what the original price was. For example, is $1 a big price increase?
Yeah.
If you're referring to gas.
Okay, well if you're talking about, let's say,
Gas.
a $100 item, and it went up $1,
No, not really.
that's only a 1% increase. Whereas if the price of a pack of gum went up by $1,
Oh my god.
well now how much is a pack of gum?
Like
$1.
Okay, so it's like $1, and if it goes up $1, that's 100% increase.
You like $2. Like 45 cents.
That sounds crazy. Okay, so if you have, let's say, a $2 item. Right now, the Gatorade costs $2. You go back tomorrow and now it costs $3. What percent increase is that? If it went from $2 to $3.
50%.
It is a 50% increase. How are you getting that?
Ooh.
It started out as $2 and went up by $1 to $3. Claire?
Since it started at $2 and $1 is half of $2, it's 50%.
Exactly, that's a 50% increase. So we're going to be talking about how to calculate increases because they make a lot more sense when you relate them to the original price. So that you can see if something's a 50% increase or only a 1% increase. Okay, now, we're also going to be looking at decreases. And whether it's an increase or a decrease doesn't matter. For percent of increase or decrease, we set it up the exact same way. The first thing we do is calculate how much the price changed. So if you have a new price and an old price, you're going to subtract them. Subtract to find the change. That's step 1. Step 2, put that change over the original price. Be careful, because the original price is not always the bigger number, not always the smaller number, it's the old price, or the old amount. And then you're going to divide it. Now we've been practicing this. When you change a fraction into a decimal, it's top divided by bottom. Top divided by bottom on the calculator, and then you can move your decimal point over 2 times and change it to a percent. Let's practice this. First example, number 1 on your notes. It says the price of a jacket decreased from $80 to $60. What was the percent of decrease? So if the price went from 80 down to 60, how much did it decrease? $20. That's the first step in doing this problem. So we know it decreased by $20. We're going to put that 20 on the top. That is the change. That's how much the price changed. Then I need the original price of the jacket. Was it 80 or was it 60? Be careful. It was 80. The original price of the jacket was 80, so that goes on the bottom. Now you punch this into your calculator, top divided by bottom. Top divided by bottom is 0.25. And then the final step is write that as a percent. What is the percent for 0.25? 25%. All right. So for number 1, our price dropped from 80 to 60, and that's a 25% decrease. All right, number 2, we're going to set this up the same way. We're going to figure out how much the price changed and put it over the original amount. So for number 2, the price of the television went from, oh wait a minute, it went up this time. It doesn't matter whether it goes up or down, we still need a change. So I'm going to take the 460 and the 400 and subtract them. How much did that price change? $60. All right, that's our change. So we're going to put the change on the top. What goes on the bottom?
400.
Excellent. Be very, very careful here. What was the old price of the TV?
400.
400. That's our original. Original price is on the bottom, and now you can punch that into your calculator, top divided by bottom. Excellent, 0.15. And now we need to change that to a percent, so we move our decimal point over 2 times. And the final answer is?
15.
Excellent, 15% increase. So our increase was a 15% increase. Yes, Maddie?
Okay, so like on the test, if you went right from 60 divided by 400, just right to 15%.
That's fine. Yep, that's fine. I'm just showing you the steps involved, and once you get the hang of this, you take care of business. We're good. Make sure you show something so I know what you're doing. That's helpful. All right, number 3. For number 3, Maria's math score on the SAT went from 470 in October of 2011 to 580 in May of 2012. What was the percent increase? Her scores went up. Went from 470 to 580. So the first thing we're going to do is figure out how much those scores changed. What kind of increase are we talking? 110. Her scores went up by 110 points. All right. So that was the change. We put our change on the top. Then we put the original score on the bottom. What was her original score on the math part?
407.
Good. Just reread for a second, make sure you're picking the right number. 470 goes on the bottom, that was her original score. Top divided by bottom. Okay, now this one you get a decimal, and it's not nearly as clean as the last 2 examples. What do you see on your screen? 2.4, wait, 2 what?
23404.
23404, blah, 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 blah. Okay, we're moving the decimal 2 times and rounding it off. So when you move that 2 times, are you going to call this 23% or 24%?
23.
Excellent. Why is it only 23 and not 24? Denisha,
Because 1 through 4 is not there, and 5 to 9 times up.
can you say that again?
1 through 4, stay on the floor, and 5 to 9 climb up the mountain.
Climb up the vine? I love it. 1 through 4, stay on the floor.
5 to 9.
I love it. Climb up the line. I love that rounding rule.
4th grade.
All right. 23% is excellent. Okay, on to the back. Here we go. We're going to talk about unit rate. When you're comparing prices or comparing items, it really helps to break it down into a unit rate. When you calculate a unit rate, you're getting a rate per one given unit. So to find this, you're going to divide the numbers. And then clearly include the units as something per something. Miles per hour, dollars per day, people per car, whatever. Make sure it's something per something. All right. Now we're going to set it up as a fraction first. When you go to make a unit rate, I want it set up as a fraction, and then you punch it into the calculator, top divided by bottom. When you set it up, if you have money in the problem, please put the money on top. It makes comparing prices a lot easier if you have your money on the top. If there's time involved, rates are very helpful if the time is on the bottom. So just keep in mind these 2 general rules. If there's money, put it on the top. If there's time, put it on the bottom. If there's neither one, then you can set it up however you want to set it up. Just clearly include your units. Okay, first example, here we go. We're going to find the unit rate. If you earn $60 for 4 hours of work, which one should go on top? The money. So we're going to put the $60 on the top. What goes on the bottom? 4 hours. Excellent. That's our time. And that's going to go on the bottom. And now you can punch it into your calculator, top divided by bottom. 15 whats? Because be careful, if you just put 15, I can only give you half credit for that.
$15.
It's $15
Per hour.
per hour. I need the whole thing. $15 per hour. So for these, you have to have units per unit. Dollars per hour. Looking good? All right. Number 5. Find the unit rate. If it costs $12.99 for 8 slices of pizza, what should go on the top? $12.99. Thank you. Ooh, Lordy. That's not what I want. $12.99. What goes on the bottom? Not yet. We'll round later. $12.99 on the top. 8 slices of pizza on the bottom. And then you can punch that into your calculator. Top divided by bottom. How much is this pizza? CJ, what do you have?
$1.62 per slice.
Excellent. On your screen, you should see 1.62375, blah, blah, blah. We're talking about money, so I want it rounded to the nearest penny. I want 2 numbers after the decimal point. So we're deciding whether this should be $1.62 or $1.63. 1 to 4, keep it on the floor. All right. So it's $1.62 because that next number was only a 3, so we don't bump it up. Now, if you leave it like that, I can only give you half credit because you don't have enough units here. It's $1.62. Perfect. Per slice of pizza, or just per slice. Please make sure you include those units. Number 6, find the average speed. For number 6, we've got 240 miles in 6 hours. I don't have any money involved. So how do I set it up if you don't have any money? Time goes where? On the bottom. So the 6 hours go on the bottom. That means 240 miles can go on the top. Punch that into your calculator, top divided by bottom. And you end up with, Johnny?
40 mph.
Excellent. Now he said MPH. That's the standard abbreviation for what? Excellent. Miles per hour. So I'll accept that abbreviation. But you could also write it out as miles per hour. All right, number 7. We're going to calculate unit rate for 2 different options. I want to buy some M&Ms, and we can get 16 ounces of M&Ms for $2.99. Money goes on top, $2.99 divided by 16 ounces. When you punch that into your calculator, top divided by bottom, you get 0.18687, blah, 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 blah. Let's round that. I use the squiggly equals to say approximately equal to 19 cents. This time I bumped it up because there was a 6 after the 8. 19 cents per ounce of M&Ms. The second option, how much money is this? $2.35 for 12 ounces. Now it doesn't matter whether the 12 is given first or the $2.35 is given first. You know that money goes on top. So when you punch that into your calculator, top divided by bottom, you get 0.19583, which is approximately equal to how much money per ounce?
20 cents.
Excellent. You can round that to 20 cents per ounce. All right, now we can compare them. The first pack of M&Ms is 19 cents per ounce. The second pack of M&Ms is 20 cents per ounce. So one of them is slightly cheaper. Maddie?
The 16 ounces is a better deal.
Excellent. The 16 ounce M&Ms is the better deal. It's just a little bit cheaper.
By 1 cent.
By 1 cent per ounce. But since you're buying 16 ounces, you're going to save yourself 16 cents. All right. Number 8. I want to buy some peanut butter. My first option is here. $5.89 for 24 ounces of Skippy peanut butter. Money goes on top, 24 ounces goes on the bottom, and you can punch that into your calculator. Now, on your screen, you have 0.245, which is approximately 25 cents per ounce. All right, my second option, the Jif peanut butter. This one is $4.45 for 18 ounces, so I put the 18 on the bottom and the money on top, and we punch it in the calculator. Top divided by bottom, and I have 0.247. Okay, wait, this one
It's 3 2
is what?
Isn't it 3 2
$2.24.
Oh, it's around.
This one rounds to 25 cents per ounce as well. Wait, does that mean the peanut butters are exactly the same price?
No,
No, there is a slight difference. Hannah, what do you see?
the one is 0.247 and the other one is 0.245, so the, Skippy peanut butter would be cheaper because it's 2 less than the, and 2, yeah.
Exactly.
than the-
This Skippy peanut butter is 24.5 cents per ounce, and this Jif peanut butter is 24.7 cents per ounce. And so this one is a tiny, tiny bit cheaper, and so we can point out that the 24 ounce Skippy is a tiny bit cheaper, so it's the better buy. All right. We're all set, finished with today's notes, ready for tonight's assignment.